All right, we are ready to begin. We are going to talk about similar polygons. Today, you will use proportions to identify similar polygons and solve problems using properties of similar polygons. So, what does all that mean? I don't know. Let's find out. Okay, so we got to remember something here with similar polygons. Corresponding angles are congruent. So the angles are going to be the same, but the side lengths are going to be proportional. So like in this case, and let me back this up just a wee bit so you can kind of see. So like right here, I'm saying that like angle A is congruent to angle W. Angle B is congruent to angle X. Angle C is congruent to angle Y. Angle D is congruent to angle Z. So that part is easy. So now let's look at what happens if I give you the sides. How am I going to compare this? How am I going to know those side lengths are proportional? Okay, so what I do is I'm going to do this. I'm going to first off, let's make sure we understand the angles again. Angle A is congruent to angle W. Angle B is congruent to angle X. Angle C is congruent to angle Y. And angle D is congruent to angle Z. But if I look at the sides, I want to see that they're proportional. In other words, that if I take one side from each polygon, so like here, AB and WX, BC and XY, CD and YZ, DA and ZA. You know, if I go around and take the sides, I should be able to take the side lengths and they should all be equal. So like 15 over 5, 12 over 4, 21 over 7, 18 and 6, all give me the same thing, 3 over 1, or just 3. Oh, wow, what does that mean? Well, that just allows us to say that those are corresponding angles. I'm sorry. I'm sorry, those are the those are similar polygons. I was going to get that right sooner or later. Okay. So, we need to know that that answer that you got when you were dividing, that ratio of the lengths of the corresponding sides of the similar polygons is called a scale factor. Now, here's the thing. Depending on how you look at it, you can say that one polygon is similar to another polygon, either the large one to the small one or the small one to the large one. And, you know, you would still be kind of correct. So make sure you kind of pay attention as to maybe the setup that you might want to say to work with to help you do this, or kind of go from there. Because like in this case, I can say triangle ABC is similar to triangle XYZ and say 6 over 3 with the scale factor of 2. Or if I go from the small one, XYZ, to the large one, ABC, then I could say the scale factor is going to be 1/2. Whoops, jumped ahead here. All right. Determine the following polygons similar. If so, write the scale factor. Okay, so here I'm going to give you two polygons, and let's say we go from the small one to large one. ABCD to JKLM. JKLM, yes, okay. So if I look at BC, whoa, again, went too far. If I look at BC and KL, saying that these two sides correspond, then I would have 8 over 12, which is 2/3. If I look at DK, now the only reason I'm going like in this way is because I like to go left to right, because that's what we're used to. So I'm just doing left to right, no big deal. So that is the reason why I went from the small one to the larger one. You could have easily switched this and still got into a slightly different answer that I probably would have accepted. We'll discuss how we might say further refine that later. But if I look at, say, DK, the small one, I'm sorry, DC, I can't even read my own handwriting now, versus ML, then I would say that's 10 over 15, which is also 2/3. So since the two sides that I have measurements for have similar angles, or those same scale factor of 2/3, then I would say these are similar with a scale factor of 2/3. Now, if I had gone from the large one to the small one, all that would have done is switch that scale factor to 3/2. It would have just made it a reciprocal. So that's really, I mean, you should, in a sense, get pretty much the same answer no matter what. Okay. So now we're going to look at, say, this example. Okay, so in this example, I want you to find the variables. Okay, we're going to say that ACDF is similar to VWYZ. Now, kind of keep that in mind, see how that is. Notice how this is supposedly kind of flipped. But look, that's also telling us that like AC goes with VW, CD goes with YW, or WY. DF goes with YZ, and FA goes with ZV. I know that doesn't seem like much, but then that means, notice here, what I'm saying here is this, that this is right here corresponds to this one right here. Okay? So make sure you're careful with how they're setting up, because the letters are telling us which ones should correspond. So the order that they go in, like AC, VW, CD, WY, DF, YZ, that tells us how those correspond. So what does that allow me to do? Well, just like we did in the last set of notes, I can say CD, which is 9, is similar to YW, or they correspond, so I can put those two together, 9 over 6, and that's going to be equal to, because I can set a proportional relationship, just like we did in the last set of notes, FD, or DF, is going to be similar to, or going to work with YZ, so X over 10. Well, how do I solve that? I cross multiply. 6 times X is 6X. 9 times 10 is 90. Divide by 6, I get X equals 15. I hate that bell. Okay, so then the next one I can say, all right, I'll use the same CD YW, because why not? So I know that's 6 over 9, or 9 over 6, I mean. And then I could say 12 over 3Y minus 1. And again, multiply. 6 times 12 is 72. 9 times 3 is 27y minus 9. Make sure that you multiply the 9 to both things in this one. Okay, so I'm going to add 9 to get 81. And then I'm going to divide 27 to get 3. So y equals 3. Alright, the only other thing I want to cover is just that there is a theorem that says perimeters are similar polygons. Two polygons are similar, then their perimeters are proportional to the scale factor between them. So that just means not only are the sides similar, but the perimeters are going to be similar also. They're going to be proportional. Alright? I'll go with the bell. It's telling me to stop for today. Let's give y'all a bonus word, because it's been a while since we've done a bonus word. So, for this one is picture. Write the word picture at the beginning of your thing, and you'll get some extra bonus points on your next test. All right? Thank you so much for your time. Y'all take care. Have a good day.